This video is on piecewise functions. A piecewise, so what is a piecewise? Piecewise are parts of different functions that have been cut and pasted. So cut and pasted together without overlapping. So we're going to have different lines. We might have 3 different lines, but they're completely different lines. They just can't overlap each other. So we don't want them to cross because we want them to be functions. And remember, functions must pass the vertical line test. What we're going to do is we're going to graph each of the piecewise functions, then we're going to list the domain and range. What this is we have 2 different equations, but we have restrictions on each equation. So this first equation, the x plus 3, we can only graph this line with regards to the x values that are at -2 and to the left. So we actually won't even graph the entire line. We can, but we'll erase the pieces that we don't need. So for the second one, our restriction will start at that -2, but not include it, and then we can go towards the right. So this equation will start at the -2 and keep going to the right. So to really look at this, I'm going to draw them in 2 different colors. I'm going to use pink for the first one, and then I'll use a blue for the second one. Now to help me, I'm going to graph out in pencil, and then I can erase it. I'm going to graph in pencil the original equation without regards to the restriction. Okay, so I'm going to graph out x plus 3. I know that in my coordinate plane, my y-intercept is at 3. I'm going to do this lightly. Then my slope is 1, 1. So I'm going to draw out part of this. But I will think about, I know I have to go, my restriction starts at -2. So instead of going to the positives right now, let's go to the negatives. So I have my coordinates so far. So I know that this would be part of the line. So now in pink, I do want to go to that restriction. So at -2, the x value of -2. Here's the x value of -2, but I have to go to the coordinate of the graph, which is right here. That's why I went ahead and did it in pencil so I can look at it. Now, because it says less than or equal to, I can put a solid coordinate on this -2, 1. Now, I want all of the x values that are smaller than -2, so that means at the -3. So I can put my coordinate for that -3, 0, and the next one would have been at that -4, then down 1, left 1, and I would keep going. And I want all of the numbers that are less than or equal to that -2. So I can graph this. It actually starts at this -2, the x value of -2, because it says I can include it. And then I want to go and connect all of these coordinates, because that's what the restriction says I can do. But because I didn't need these, I'm going to erase these dots, because that was from the part of the graph that I'm not allowed to have. So I'm going to do the same thing in pencil with my second one. I'm going to graph this part of the beginning so I can figure out which coordinates I can use. I will show another one in the calculator. So at first I'm just going to graph this by hand. So I'm going to go to +5. Then my slope is -2, right 1. So -2, right 1. So I have quite a few here. Now I'm going to go the other direction as well. So up to left 1, up to left 1. Okay. Now, in my blue, I have to go to that x value of -2. So here's my x value of -2. But then I have to go find the graph of what I was just doing. So I have to come all the way up here. So there's my first coordinate. But because it is an open circle, I have to make sure I put an open circle on here. I cannot keep going to the left. So I couldn't even go up to and left 1 again, even if I wanted to. I need to go to the x values that are bigger than -2. So if I go to the -1, that coordinate is up here. I can put a coordinate there, a solid dot there. The 0 would go to that +5. I would keep going. Negative down to right 1, down to right 1. I would keep going because I want to have all of the x values that are bigger than -2. So I would keep going with down to right 1. As many coordinates as I possibly could. Then I would connect them. This is a piecewise. I have a piece of the pink graph and I have a piece of the blue graph. If I had kept going, then these would intersect, but that's not what we're trying to do. We want this to still be a function. So as you can see, I have 2 coordinates here on this x equals -2. But this one is open, so it is not including that x value. This one is closed, so it is including. So I really only still have one x value at that -2. So this would still be a function. Now is when we have to find the domain and range. This is a discontinuous graph, so we have to mind the gaps. So for the domain, we do have an arrow pointing left, so that will have a -infinity, and we do have an arrow pointing right, so that will be a +infinity. But we have to check the graphs, or the gaps. So we know it's going to start at a -infinity. And we need to know where it's going to go to. So this arrow, I want to go from, if I had highlighted this in blue and then highlighted that in blue, I know I would have to jump. But as we're going to the right along this graph, I have to stop. If we remember back from domain and range, if I can jump up and down without continuing to move right, then I'm okay. So I have to look if there's anything that I can go to on this line. There is. So if I can continue moving right from here without hitting a blank spot, then I'll be fine. If I continue moving right, I hit this blue and that's good. So I can keep going right, right, and I would hit the arrow. So I actually don't have any gap in my domain. So I can still write as -infinity to +infinity. Now for the range, we do have 2 arrows pointing down. So if I were to highlight this one, if I were to start here, I would need to go from my lowest point to my highest point. My highest point is up here. If I went from this arrow up, stop, because I couldn't keep going up because there's no more pink, I would need to see, because I can't go up yet, I need to see if there's anything I can jump to on the side, so I could keep going up. I can jump over here, and I could continue going up to the stopping point. Now, if I had just said I wanted to start from this one, I could actually get to that stopping point without having to jump. So our range, that smallest value is that -infinity, and it's going to go up to that 9 without stopping, and that 9 is going to be an open circle. So our range is -infinity to +9. So on this one, we graph the equation, and then we erase part of it. You can also still do this in your calculator as long as you mind the restrictions as you go. So again, I'm going to use pink and blue to graph these. So what I'm going to do is, in my calculator, I'm going to graph the first one. I'm going to graph the first one without looking at the graph at all. I just want to go to my y equals. I'm going to type in 2x minus 4. Now, I don't want to graph it. I don't want to see the graph. I just want to get coordinates. I'm going to go to my table, but I have to go to that x value of 4. So that's my first stop, x value of 4. Then I want all the x values that are smaller than 4. So I can graph from here as much as I can up. That's why I'm going to graph in pink. Now, at 4, 4, Because it says less than but not equal to, I have to have an open circle when my x value is 4. So my coordinate is actually 4, 4. So I can graph 4, 4, but I have to put an open circle there. Then I want less than that x value, so I'm going to move up. So my next coordinate would be 3, 2. So 3, 2. And I can put solid because I want all of these values. The next one would be 2, 0. Then 1, negative 2. And then we can see that it's going to just keep going down. So I'm going to go down 1 and down 2 and left 1. Because that's the pattern that's going on. So I'm going to do the same thing. And then we can still check our coordinates. So I have 1, negative 2, 0, negative 4, negative 1, negative 6, negative 2, negative 8, and then negative 3, negative 10. So these are all good. So I can connect these. For the blue, I'm going to do the same thing. I'm going to go into my y equals and type out negative parentheses, 3 divided by 4, close parentheses, x plus 11. Now again, I'm not going to actually graph it. I want to look at my table. So if I go to my table, second graph, I go to that x value of 4. That's the first one I can go to. Now it says I want greater than or equal to the 4. So I would actually keep pressing down. So my 4, I want to be at the very top because I want all of these values down here. So my first coordinate would be 4, 8. And it's solid because I can start at the 4. So 4, 8 is going to be a solid circle. So 4, 8 is solid circle. Then the next coordinate we could graph would be, these are a little, I don't want to try and graph those are decimals, but the next one is 8, 5 is a good one. So 8, 5, I could put a solid circle there. And you can put other ones that would help, but to make it as accurate as possible if you wanted to. But I would just keep going down. My next good one would be 12, 2. So it would be somewhere around in like here or something. But remember, we want only from here and connecting those points, nothing to the left. So I want to go from this coordinate through these coordinates as much as I can. And then I put my arrow. This is the piece of the first one. This is the piece of the second one because of the restrictions. So now let's do our domain and range. So domain. We have an arrow that's pointing to the left, and we have an arrow that's pointing to the right. So we will hit both infinities. So it's going to start with negative infinity to what? So this one, if I want to go from this arrow to that arrow, I would go along the pink, right, stop. But this is open, so that's actually not, that's not there. But if I have anything solid, since I kept going to the right, I have to check up and down if there's anything solid. There is something solid here, so I can actually jump to this one to see if we can keep going right. I can keep going right along the blue and hit the blue arrow. So there's, even though there's a jump, there's no gap in the domain. So it'll go from negative infinity to positive infinity. For the range, I have a arrow pointing down and also an arrow pointing down. So both of these arrows are pointing down. That's definitely a negative infinity. And then the highest point is up here. So we have to get from, if I use the pink one, I need to go up. So this is going to be definitely a negative infinity to something. So I go up, stop. But this is open, so it's not actually there. Since I was going up, I look to my left or right to see if I can hit something solid. And I can on the blue. And I can actually keep using the blue to continue going up until I have to stop. And there's nothing else to be graphed. So that's the highest. And there was no, even though we had a jump, there was no gap in the range. So it went up to that positive 8 with a closed bracket. And again, I still could have used my blue one because that also represented negative infinity. And I could have gone from blue, the bottom blue, to the top blue because that was my highest point without stopping. and it still would have been fine.